Question 19. The scale drawing shows the positions of two towns A and B. This is town A and this is town B. Scale 1 to 50,000. This scale is in centimeters. So this is 1 centimeter to 50,000 centimeters. This is 1 centimeter on paper to the actual 50,000 centimeters on land. You should know that. Town C is 3 kilometers from town B. The bearing of town C from town A is 40 degrees. That's on the 3-figure bearing. Draw the two possible positions of town C. These two lines are very crucial in solving this question. Town C is 3 kilometers from town B. If town C is 3 kilometers from town B, we have to convert 3 kilometers to centimeters. Then from centimeters, we now scale it using our scale of 1 to 50,000. Note that the 3 kilometers is the actual land measurement. That's the 3 kilometers distance from town C to B is the actual land measurement. And we need to convert it to paper measurement. To convert it to measurement of paper, as just said, we need to convert it from kilometers to centimeters first. You might be good at doing it in the sense that 100,000 centimeters equals 1 kilometer. You might know how to do it this way. Or you might convert it, that's 3 kilometers to meters first, then from meters to centimeters, depending on how you can do it. Now, for those who might not know how to convert directly from kilometers to centimeters, from kilometers to meters, you have 1 kilometer equals 1,000 meters. So you convert 3 kilometers to meters, you can say it's x meters. Then you cross multiply. Anything times 1 is that same thing. So you have x times 1 as x equals, on the right of the equals sign, you have 3 times 1,000. That's 3 times 1,000 will give you 3,000. So this is 3,000 meters. We're not done because the scale is in centimeters. So we have to take it from 3,000 meters to centimeters. How many centimeters make a meter? You have 100 centimeters equals 1 meter. Then you have to convert 3,000 meters to centimeters. Under the 1 meter, you put the 3,000 meters that share the same unit. So you have 3,000 meters is equivalent to what value in centimeters? You cross multiply again. X times 1 is x equals 100 times 3,000. You have 100 times 3,000. That gives you 300,000 centimeters. So converting from kilometers to centimeters, you can first convert from kilometers to meters, then from meters to centimeters. Or if you understand that 100,000 centimeters equals 1 kilometer, you can convert it directly. It's 100,000 centimeters equals 1 kilometer. Then 3 kilometers equals what value in centimeters? Let's say it's y. So you cross multiply. Y times 1 is y equals 3 times 100,000. 3 times 100,000. That's 300,000 centimeters. Either way, you still get 300,000 centimeters. We've now converted 3 kilometers to centimeters, and it's 300,000 centimeters. You have a scale. The scale is to help you get the actual value on paper. The scale says 1 centimeter to 50,000 centimeters. That's 1 centimeter on paper equals 50,000 centimeters on land. And we know the actual value on land in centimeters is 300,000 centimeters. So we convert 300,000 using this scale to its value on paper. So use our scale. 1 equivalent to 50,000. Then we're converting 300,000 centimeters to its centimeter value on land. So we write it under the land value, which is 300,000 to the right of the equivalent sign. It's to what value on paper? Let's say the value is B. Now we cross multiply. You have B times 50,000 on the left of the equals to sign equals 300,000 times 1. B times 50,000 equals 300,000 times 1 is 300,000. Since we're looking for B, which is measurement on paper, we divide both sides by 50,000. We divide by 50,000 by 50,000. The 50,000 is linked to the b by multiplication. So to get it off, you have to divide both sides by 50,000. So 50,000 cancels 50,000. You'll be left to b here equals 300,000 divided by 50,000. The 3 zeros behind cancels themselves out. Then this 0 cancels this. You'll be left with 30 over 5. That's 30 divided by 5 is 6. So the measurement on paper, or the value on paper, that is the distance between town B and town C on paper, is 6 centimeters. Now that we have gotten this, we use this in solving the question. That says, draw the two possible positions of town C. C on paper is 6 centimeters away from B. Since you don't know the actual location, and as said in the question, there are two possible locations for C. That means you have to make a circle of radius 6 centimeters around B. You have to use your compass and a ruler and stretch it till you get 6 centimeters. Then put the pinpoint here, and with the pencil point you make a circle round B. The circle goes in this way. We're doing a sketch work of it with a radius of 6 centimeters round B. Then at A, since the location or the bearing of C from A is 40 degrees, you use your protractor in this case. First, you make your 4 cardinal points at A. You get your horizontal line at this point A, then you drag your vertical line down. Then with your protractor, reading from the north, since it's a 3-figure bearing, not a compass bearing, you get your 40 degrees. Then you draw a line that joins the center of A with the 40 degrees mark you made with your protractor down to cross the circle. So you have it like in this way. And with this, we get the two possible points for our C, which could be this point or this point. That means C could be here or here. To actually do the construction or solve this question on paper, first you need your ruler. At point A, you make your 4 cardinal points. That's, you pick your ruler and your pencil. You extend the vertical line. You make your cardinal points at A. For B, since we know the distance between B and C is 6 centimeters on paper, we get our compass. Put the pin end at the 0 point. Then we extend it to 6 centimeters. Now once we've done that, you take your ruler off. You take the compass. Put the pin end at point B and make a circle round point B. That's 6 centimeters. C can be on any point on this circle. That's showing the 6 centimeters distance between B and C. And statement 2 also says C is on a bearing of 0-40 degrees. That's on a 3-figure bearing of 0-40 degrees from A. So now we'll take our protractor. At A, taking your reading from the north, you get 40 degrees. Then once you get your point with your ruler and point A, you draw a line across the circle. So let's focus on that now. We'll take our protractor next. We have our protractor here. And since our reading is from the north, it's best you start your reading from here, which is 0, and just make it vertical. Once you have it vertical, you make sure this 90 degrees line aligns with the east of A, because your reading is from the north, so your 0 point will have to be from here, 0, 10, 20, 30, 40. You put it here, make sure it's there, you balance it. Now that it aligns, and it also aligns vertically, it should align horizontally and also align vertically. And this is your point 0, this is your north. You have 10, 20, 30, 40. This is your 40 point. Once you made the point, which is here, you're done with the protractor, you can get it off. Then you take your ruler. Let's make it longer. At point A, we draw a line through the 40 degrees point made with our protractor across the circle. Now that we have this, we've drawn a line from point A past the 40 degrees mark on our protractor across the circle. We've gotten the two possible values for C, which is either this point or this point. Because on these 2 points, C is 6 centimeters away from B, which is also 3 kilometers on land from B. And also these 2 points are on a bearing of 40 degrees from A. So this point and this point are the two possible locations for point C.